Okay, I'm going to sketch the trend line for this data. Do my best to sketch an honest trend line. Okay, that's could be improved upon, but we can work with this. I want to choose some point at which to start, and I'll start out here someplace with this point. I'll come down, right there is a point on the x-axis, and I'm going to cut that distance in half, putting me about here, and that's going to correspond to a point about here, and I'm going to cut that distance in half, giving me a point about here, so that my y coordinates are here, here, and a little higher than that. Okay? Now, what is the y factor as we go from this point to this point? In other words, x doubles from here to here. What's the y factor? Okay, so well, in the first place, it's pretty clear, or it should be pretty clear, that the y factor is less than 1. You should multiply this. If you multiply this quantity here by something more than 1, it's going to get bigger, but it's getting smaller, so the y factor is less than 1. Now, if I take half of this number here, I get about this. Is that right? Let's see, that's about half. No, half should be a little lower than that, about here. Okay, so half of this quantity is down here. This is clearly more than half. It's probably, okay, halfway between here would be this. So this would be 0.75, this would be 0.5. So I'm saying that's probably, I'm going to guess a y factor of 0.67. That's the way I eyeball this one. There are plenty of ways to do this. You take a ruler and measure it, all kinds of things you could do. Now, in looking at this, I'm not sure that I really did a good job of cutting this in half. Okay, this point, if this is half of this, then this really ought to be out a little further. So I'm going to kind of relocate this point, and I'm going to kind of erase that. Matter of fact, I'm going to get this thing, and of course I could have done this in advance. I could have done it very accurately without having to redo anything, but I want you to see the process. So I'm modifying my estimate here, and you should feel free to do the same, as long as you're not modifying your estimate because you think you got it wrong. You make an honest estimate of the doubling distance, but as I looked at this, this was a little too far over yet. So here we go. So that's about where this point should have been. So we'll smudge that out there. Okay. Now let's look at what the ratio is here. If I take half of this, let's see, should be more like here. Okay, so here's half, and if this is 0.5 of this, then I think that's really pretty close to 0.6. So I think my factor is 0.6. Now, if it had been up here, I would have thought that 0.67 was pretty close. Okay, so when x doubles, it appears that y changes by factor 0.6, 0.67. I'm going to kind of hedge the two and say 0.64. Okay, so maybe y factor 0.64. Now you can make your own judgments, and you can use your own data to do your own graph and determine the y factor that you think should work. Okay, so y factor of 0.64. Now that means that P, that implies that P should equal the log of 0.64 divided by the log of 2. And I think that comes out about 0.55. I'm doing that by a kind of an honest mental estimate, and I could be off, but I think that's probably going to be around 0.55. So that means that our model should be what? Well, should be, just trying to decide where to write this. Okay, our model should be of the form y equals ax to the 0.55, and actually I got hung up on doing the number, but it should be negative 0.55. Okay, so here's our model. Now if we have one data point, we can determine the value of a, so we get our model function.